In this question we're given two functions, y1 and y2. We're supposed to graph both the function on the same set of axes, and then we're also going to determine the interval for which y1 is greater than y2. So I know that this y1 has a intercept of -30, and I know that y2 has a intercept of +12. Right now that's pretty much all I know. Let's find the x value for the vertex. So for this one, actually maybe what I'll do is I'll put both of these in vertex form, and that will give me an idea of what's going on. And then I'll also find their intersections, and that will really help me graph this. So this first one, y1 equals x squared minus 6x, make some room, minus 30. Take half of 6, which is half of -6, which is -3, and square it, and we get +9. And I just added 9 to this. I just moved it up 9 units, so I need to make sure I move it back down 9 units so I don't actually change anything. So now y1 is equal to x minus 3 squared. You can see that this is the exact same thing as this, except written as a perfect square, minus 39. So this first function down here, it's going up, and it says it's moved 3 units to the right. So we'll say this 1, 2, 3, and it's down 39. So somewhere right there. And it goes through -30. Okay, looks like that. The second function, do it in purple, so y2 is equal to -x squared plus 2x, and move the 12 over. What I'm going to do first is I'm going to factor out a negative. So -x squared, factor out the negative from the 2, so I have a -2x, and then I'm not going to factor it out of the 12, I'm going to leave the 12 out there. Okay, half of 2 is 1, half of -2 is -1, square that and I get +1. So I don't subtract 1 here. That's a very common mistake. It's not -1 because I didn't add 1, I actually subtracted 1. So this is a negative times a positive, so I have to add 1 here. That's -1 that I've just added to this equation, so I have to make sure I move it back up to 1. Very common mistake to ignore this. Okay, so now y2 is equal to -x minus 1 squared plus 13. So this one says to go -1, so over 1 and up 13, and it's going down. Something like that. Okay, so now let's find where these things intersect. So let's just set them equal to each other in standard form. So that's x squared minus 6x minus 30 equals minus x squared plus 2x plus 12. Let's bring this over. We get 2x squared. This over, we get minus 8x. This one over, we get minus 42 equals 0. Divide everything by 2, we get x squared minus 4x minus 21 equals 0. Let's see if we can factor it. X, 7 and 3, and then a minus 7 and a plus 3. Just make sure it works. I get x squared here. I get plus 3x minus 7x. 3x and minus 7 does add to be minus 4x, and then 7 times 3, -7 times 3 is -21. Okay, so this means that they intersect at 7, and they also intersect at minus 3. So if I continue these graphs, see if I can kind of do this. So that's 3, 4, 5, 6, 7. Continue this one, and then draw this one down. Very ugly, sorry about that. And then minus 3. Minus 3. So it's minus 3, and that's 7. Okay, that's good enough for me. Not the greatest graph. So, determine the intervals for which y1 is the blue one, and y1 is greater than y2. So when is the blue one above the purple one? Well, that happens when x is less than negative 3. Is it equals to? Less than or equal to. So less than or equal to negative 3, or when x is greater than or equal to 7. So those are our two answers. Now I just want to take a second and talk about this question here. Let's say that I decided to do the inequality all the way through here. So when is this one greater than or equal to, greater than or equal to, greater than or equal to, greater than or equal to? So at this point here, the algebra actually stops. You want to know when this function here is greater than or equal to 0. So what I like to do is I like to come over here, draw a little axis. This is 7. This ends up being minus 3. And you know that this graph, which represents the intercepts of this graph, or these two graphs, is positive. See, it's positive 1, positive, goes up. When is this quadratic, which is positive, greater than 0? Well, that's over here, which we see we have the same answer here, and up here, which we also have. So the algebra sort of stops here, and you need to draw a little graph just to think about it graphically instead of algebraically. I hope this helps.